Today we're going to mark your homework, which this week was the Electricity 2 exam. What you need is a blue pen and a green pen ready for adding in corrections and annotations. Okay, let's go through the first question. We've got a table with 5 electrical components and we've got to fill in the missing gaps. So the first one is a switch, which allows current to turn off and on. Second one is a variable resistor. To draw that you need a long rectangle with an arrow through that. Number 3 is a diode, only allows current through in one direction. Fourth is an ammeter, which measures current, is the function of that. I've just made a quick note to remember that we always connect ammeters in series, voltmeters in parallel. And the final one is an LDR, whose resistance changes depending on the light intensity, and to draw that you have a normal fixed resistor, which is your long rectangle, with a circle around it and 2 arrows to show the light shining on the resistor. So that's your first one, and that's 5 quick marks. Suggest why it is important that all scientists use the same symbols for electrical components. So I need to give a reason. And there's 2 things you could say here. The main thing is to say it's to avoid misinterpretation. So what you don't want is using capital E for efficiency and capital E for energy, and somebody interpreting that as efficiency when actually you meant energy, for example. Or you could say it's so that if you're speaking different languages, scientists who speak different languages, they can still identify the symbols, even if they don't speak the language. Good little picture of a lift there, but very nice. The motor in the lift does 120,000 joules of work in 8 seconds. So just note here, my figures are given to 2 sig fig, so I'm just going to make a quick note of that so that when I come to give my final answer I can use 2 sig fig too. Calculate the power output of the motor of the lift. For this question I'm going to first write down what I know. So I want to calculate power, and I do need to box that off. I know that the energy transferred is 120,000 and the time is 8 seconds, and I know that power is energy divided by time. Energy transferred, I know it's 120,000 energy transferred, joules of energy transferred, because work done equals energy transferred. I can write that then as 120,000 divided by 8, summing my values, and if I do that calculation it gives you 15,000 watts, rounding to 2 sig fig. And I've rounded to 2 sig fig because my values in my question were to 2 sig fig. The power output of the motor is greater than, so the power input is greater than output. Tick 2 reasons why. We're going to work through these one by one. I'm going to put a little tick on the left hand side so I'm not interfering with my boxes if I think it is a good reason, and hopefully we'll end up with 2 ticks and then I can transfer those in. If I end up with 3 or only 1, then because I haven't interfered with my boxes I can just have a closer look at those. Energy is transferred into heating the surroundings. Yes, that's true, and it would explain why there is more power input than output, so put a little tick there. Friction causes energy to be transferred in non-useful ways, while efficiency is useful power input divided by total power output, so yes, that does make sense. The motor is connected to the mains electricity supply. Well, that's true, however it doesn't explain at all why there's more power input than output. the motor is more than 100% sufficient cannot be true, because you cannot be more than 100% efficient. And there's no one in the lift. Well, that is also not going to tell you at all whether the power input is greater than the power output, and we haven't actually been told. So I'm going to say my two correct answers are the first two. I've now got a circuit showing our lift, so we've got some power in, a motor. We've then got in parallel two switches and going around. The lift can be operated using either of the two switches. Why? If switch 1 was closed, then the current could flow through switch 1. If switch 1 was still open but switch 2 was closed, then the current could still flow through switch 2, and that's because the two switches are in parallel. So what you need to write down for that is the two switches are in parallel, so you get a complete circuit when you close either switch. Closing either switch completes the circuit. And I've got an explanation because I've written so or therefore. Question 2D is another calculation question, so make sure you're bugging as you go. The lift goes up 14 meters, total mass is 280 kilograms, gravitational field strength 9.8, and calculate the increase in gravitational potential energy. And it's specifically telling me here to give your answer to two significant figures. So I need to remember that at the end. Again, writing down what I know. I want to calculate energy transferred, which is gravitational potential energy transferred, or we can call it EP. The mass I know is 280 kilograms, and the gravitational field strength and height I know is 14 meters and 9.8. Energy transferred in the potential store, or in the gravitational potential store, is m times g times delta h. That's my formula. All I need to do is then substitute in my values, and I will get 38416. However, remember we needed to give this answer to two significant figures, so my final answer is 38,000 joules. If you did not write it as two significant figures, then you would have lost 1 mark, so you would have only got 2 marks out of 3. Okay, next question then. People investigated the current, potential difference and resistance of a parallel circuit. They've got two resistors in parallel. So I've got my cell, and I've got, I'll do this as annotations actually, current flowing. At this junction, the current is going to split, and you can remember that the current splits in parallel. If you remember this table, we have current, potential difference and total resistance. Current in series stays the same and in parallel splits. PD in series splits, in parallel stays the same, and we don't actually need total resistance for this question, but this also can help you to remember how to calculate total resistance. So the current's splitting into these two, but the potential difference is staying the same. So we're looking at a parallel circuit. Complete the following sentences about the current and potential difference in the circuit. the total current from the battery is, well, the total current splits up and then rejoins back together. So the total current is adding up current in each one, because they need to add up when they join back together. And the total potential difference stays the same, so it is just the same as V1, which will be the same as V2. And just used the wrong colour pen there, I apologise. A1 plus A2 and V1 equals V2 is what you should have written. Got some more sentences to complete. Complete the following sentence about the resistance in the circuit. The effective resistance of the two resistors in parallel is, now here I will need my resistance column. Total resistance in series we don't need, in parallel is lower than the lowest resistance. If it's lower than the lowest resistance, it also has to be lower than the sum of R1 and R2. Sum of R1 and R2 means R1 add R2. So if you add them together, you must have a bigger number than just the smallest one, so we need to say less than. We've now got a graph of resistance against temperature. This is for a thermistor. If the resistance is changing because of a temperature, that must be a thermistor, and you can remember that is your hockey stick through your resistor shape. And that was giving the name. To identify the pattern between temperature and resistance, we always start with as, and we say the value on the x-axis, so as temperature increases, and we read it from left to right. As temperature increases, and in this case, as temperature increases, resistance decreases. So that will be your first mark. We then need to say, if it's a straight line, we would say they are directly proportional, and if it is not a straight line, we say they are not directly proportional, so we say not directly proportional. Another way of saying that is it's a nonlinear relationship. Final question that we've got is, a lamp is connected to 230 volts, 4 amps of current and 30 seconds. Write down the equation that links charge, flow, current and time. Charge flow is current times time, or Q equals IT. You just need to know those. Calculate the charge that passes through the lamp. Okay, let's write down what we know and what we want to find out. We want to calculate the charge, so charge is some number of coulombs is your units for charge, which is a capital C. The current is 4 amps, the time is 30 seconds. Q equals IT, as I've already written, which is 4 lots of 30, which is 120 coulombs. The energy then transferred by the lamp, you need to use your equation E equals Q times V, where E is what you want to find out, Q is 120 coulombs, and V is 230 volts. You've just already worked out the Q from your previous question. The 30 seconds is the same. So we can just use 120 coulombs for Q, 230 volts for V. Substituting into your formula gives you 120 times 230, and it does specifically say give your answer in standard form and give the unit. So that gives you 276 27,600, sorry. 27,600 joules. And I haven't yet had to think about significant figures. It doesn't tell me what significant figures to give it to, so I need to look at my values, which helpfully I've already underlined when I bugged. 230, that's to 2 sig fig, 4 amps is to 1 sig fig potentially, and 30 seconds is to 2 sig fig. I'm going to give my answer to 2 sig figs. This is the same as 28,000 joules to 2 sig fig. But I also need to give it in standard form, so my final answer is going to be 2.8 times 10, and I need to move my decimal place 1, 2, 3, 4 times 10 to the 4, and that is in joules. Okay, what you need to do now is add up all your marks. You should have a total mark out of 30. And right on the front of your paper, you're writing your final score. Might be 22, for example. Thank you very much, and